Have you ever wanted to create a spiraling form in Revit? I recently had to create a helical pile and I was so confused. It took me so long to kind of figure out what I needed to do. And honestly, shout out to this blog post that kind of gave me the foundation for how to do it. But the one thing that I couldn't find were videos on how to do it. And I was so proud of myself when I finally figured it out. And I was like, I have to make a video about this because I know I'm not the only one who was struggling to try to figure this out. And I know it's been a minute. We're not going to talk about it, but I'm here today and we're going to talk about how to create spiral forms in Revit. Also, if you're new here, I'm Chelsea from thestudentarchitect.com, where I create tons of resources for architects and architecture students. Now let's get into it. So this is pretty much the shape that we're going to be creating today. So it's this kind of spiral form here. You can see it's kind of divided into two separate shapes, and we'll get into that. But yeah, this is a pretty complex form when you really think about it. And it's really confusing if you don't know the tools that you can use to create it to figure out how to make this work. So you can apply this method to all kinds of different things, but today we're going to create a helical pile. We're not really going to do this kind of like chamfered bottom part, but we will do this part. All right, so I'm just going to open up just a generic project in Revit. And I just started from a built-in Revit rounds column. So CL on the keyboard to add in a column. Here we go. We've got a pipe column already in here. That's amazing. So I'm just going to place it in the project and double click to open the family. So this is basically all we have here is just a cylindrical pipe form. So let's go to the floor plan, and we've already got some dimensions here. Now for the helical pile portion that we're going to be creating, that's a 12-inch diameter, 1 foot diameter. So I'm going to add in some reference planes here. Also, forgive me, it's been some time since I've done this, so I'm probably going to be making some mistakes. Okay, so we're going to measure from the center line. We're going to make sure these center lines are pinned. Perfect. We're going to equalize and dimension here. Equalize. And so that helical width is going to be, it's going to be the same on both sides. So we'll select both of these. We'll add a new parameter here for the width. And that will be a type parameter, and we'll hit OK. And let's change that to 1 foot. All right, I think that's the only dimension that we need on the floor plan. Now let's go to an elevation. Let's go to the front, and we'll work from the bottom up. So I'm going to add in some reference points here. So one I'm going to add in for how far from the bottom that helical base is going to start. Then I want another one for the center of where like the center point of that spiral is going to be. And then I want another one for the top. And so if you have a shape that you want to spiral many, many, many times, you're going to need a similar system to this all the way up. Or you could, if you don't want it to be parametric, you could just do one and then copy it if you wanted to. But I always recommend doing things parametrically. Okay, so from the bottom to the bottom of the helical, then we want this to be EQ, because we want that to be centered, and then the height of the helical we also want. So let's say from the bottom we want this to be like 6 inches. So bottom of helical to base, something like that. Again, we'll make that a type parameter, and then we'll put another one here for helical height. Okay, again, a type parameter. So let's make this 0.546 inches. And let's make this, let's say the helical height is going to be 3 inches. And since we have the EQ here, this one, the center reference plane is going to be in the center regardless of whatever height we make this. So if we change in the future to make this be 6 inches, our form, our shape is going to, what's the word? It's going to like morph to match whatever whatever it needs to be to make that work. So again, let's put that back to 3 inches. And now basically all of the like initial setup is done. Now what we need to do is start making that form. So let's go to the reference level. And how we're going to do this is we're going to create a blended sweep, a swept blend. So the way that this works is you create one profile for one end of the sweep and then another for the other end. Actually, I lied. There's one more thing we have to do before we do that. Let's go back to the front. Now we need to label what these reference planes are. So this is helical bottom. This is helical middle or center, whatever you want to call it. And this is helical top. The reason that we are naming them is that we're going to need to pick the reference plane that the profiles are set to as we're creating the sweep. So let's go back to the reference level. We will create swept blends, and we're going to sketch the path. So the thing about this is if you want your shape to return on itself or create like a 360, like a full circle, you're going to have to break it into separate parts, because other than in railings, that's kind of the only thing that I can think of that you can kind of return a shape onto itself. It doesn't work with other forms in Revit. So you're going to have to break it in half, which is why in the beginning you could see there was a line separating the two shapes. So we're going to create half of the circle right now. So I'm going to, we're going to use this shape here. We're going to do it this way so that we can have the helical start here and end here at the middle. And we'll make this parametric as well. And we will name this radius. And that will be a type parameter. And we can figure that out after we create the shape. Okay. Now we're going to enter the profiles. So we're going to go to the right. And this is where the naming of the reference planes comes into play. So actually, let's go into the 3D view. Let's double click on the path, and we're going to set this to a work plane. We're going to set it to the helical bottom. Hit OK. Now if we go back to, let's hit the check mark. Now if we go back to the right, you can see that it's no longer at the bottom here, and it's assigned to that bottom reference plane, which is exactly where we want it. So profile 1, you can see this one is highlighted here. So this is the front of that pile that we were looking at, and this is the back. So we want to start with this one here, and we'll edit the profile. I'm going to use the pick line tool, and we'll lock. So I'm going to pick here, 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 and then the last one I'm just going to, sorry, the last one we're just going to draw on a line, and TR on the keyboard to trim the corners. And now, double escape to get out of the command, I'm going to dimension to get the height of this. So DI on the keyboard, we're going to dimension from the reference plane, not the sketch line, and then we'll dimension to the top sketch line. And the height of this, let's make a new parameter for helical thickness. Sorry, words are taking time to get to my brain right now. Helical thickness. Again, we'll make this a type parameter, hit OK. And let's just say this is going to be 1/8 of an inch. And we'll hit OK. So we've created one part of this sweeping shape. Now we'll edit profile 2. And something to keep in mind is that these shapes don't need to be exactly the same. They will be for this example because that's what I need it to be. But they don't need to be. Okay. So profile 2. So while the first one we aligned to the bottom of this reference plane here and built up is because this is the bottom of where we want that helical to start. But for the middle, it's going to be centered because it needs to be equally accessible, or it needs to meet in the middle of both of the bottom and the top. So if we aligned it to the top or the bottom, it would be either above or below the shape above or below, if that makes sense. So this one's going to be a little bit different. So we'll sketch this profile, edit the profile. We will still lock and align. So again, make sure you have the lock checked on. We will still lock to these two reference planes. However, for the top and bottom, we're just going to have to draw these ones in. Again, TR on the keyboard to trim the corners. Double escape to get out of the command. DI on the keyboard to dimension. So we're dimensioning from the center line to the top and bottom. And we're going to equalize that. And now what we're going to do is we're going to dimension the whole thickness, and we're going to apply that thickness, helical thickness parameter to this shape here. So now you can see it's equally above and below this line here so that it will meet both of those shapes at top and bottom. Okay, so now we can hit OK. Hit OK again, and look at that! We have the first part of our helical shape. How amazing is that? So cool. So now we just repeat the process for the other side. But the thing that we want to do is when we create the new shape, we want to make sure that we've reset that the work plane to the middle reference plane. All right, so let's do this. We'll go back to the floor plan. Actually, before we do that, before we forget, let's go into the family types box, and we need to create a formula here. So this is the diameter, and we created a parameter for the radius. So all we need to do is type in diameter. Let's type that right. Divided by 2. And that will give us the radius here. Oh, looks like we already have some of those. Anyway, so that's not a parameter that we need to change ourselves. It's going to be dictated by whatever size pipe you choose in the future. So I'll hit OK. And now we can create a new swept blend on the other side. So we will sketch path, set the work plane to helical middle, hit OK. Again, we will create our shape, add our radius parameter here, so that if the pipe size changes, the helical form will morph along with it. Let's hit OK. Let's go to the right side again. We'll go to profile 1, and that's going to be on this side. And we know that because it's highlighted. So sketch path. Oops, sorry. Edit profile. And also when you edit the profile, this one is a more vibrant color and this one's grayed out. So again, just to help you kind of understand which one you need to work with. Again, we'll use the pick line tool, make sure lock is selected, click on the reference plane here, click on the reference plane here, and then these two we'll just draw in manually. TR on the keyboard to trim the corners. DI on the keyboard. Oops, sorry, double escape, DI on the keyboard to make sure that it's equally on either side of that middle line there. And then again, select the bottom, select the top, or top then bottom. Double escape, click on that dimension, and we'll add the thickness parameter. Okay. So 1 is done. Now we'll do profile 2. And we'll do the first, oops, sorry. Edit profile. And then now this one, we will do the top reference plane, the sides, and then we'll draw in the bottom because again, we want that to be the top of the, where the helical form ends. TR on the keyboard to trim up the corners. Double escape, DI for dimension. Again, we'll click on the reference plane, not the shape. Apologies if you can hear my neighbor's dog. So we'll click on the reference plane and then the bottom line here, sketch line, double escape, click on the dimension string. We'll find helical thickness and hit OK. Hit OK again, or the check. And look at that. We did it. It's so crazy. And so now if we decide we want to go in here and make some changes to anything, let's say we want the helical width to be 2 feet. It's going to expand. Let's say we want the thickness to be 1 inch. It's going to get thicker. Let's say we want the helical height to be 1 foot. Okay, that's a little too much. Let's do 6 inches. It's expanding. So that is what I mean when I talk about parametric families, is making sure that they can morph to match many different needs rather than just one specific instance. So yeah, that didn't take very long. That took, okay, according to my timer, it took us 21 minutes. That's not bad, especially when it's something that you can use for many different purposes. And this is like a skill that you can use for a lot of different things that I, for some reason, can't think of right now. But there are a lot of use cases for this. Like if you needed to model screws for some reason, or some kind of, maybe you have a decorative trim around the exterior of your building or the interior of your building, something like that. This is a really easy way to do it. And I've seen a lot of tutorials using adaptive families and things like that. If you're a Revit LT user like I am, I'm a proud Revit LT user. You don't have access to those tools. And also, I think they're sometimes a little more complicated than they need to be. This was a pretty easy process to be able to create this. The only issue I have with this is this line. I haven't figured out yet how to merge these shapes in a way that it allows. So if I hit JO on the keyboard to join and I try to join these forms. Okay, now Revit's playing with me because when I tried to do that on my other, let's bring in the OG family. Let's see. Why wouldn't it let me do that before? You're seeing this live. J-O, can't join them. Why did it work on the other one? I don't know. Well, hopefully you're blessed like I was on this new one and it works properly. I don't know why it didn't work on this one, but I really hope that you enjoyed this video and that this helped you expand the number of things that you're able to model in your projects. This was such a cool and exciting thing that I was able to figure out, and I was so excited, and I just had to share it. So I really hope that you found it helpful. If you like this video, please like, subscribe, share with your friends, share with your enemies, and I'll see you next time. Hopefully it won't be nearly as long as it was this time around, but I hope to see you soon. All right. See you later.